What's up, physics fans? This is Dover Animatrix, Physics 12. This is going to be question 16 from page 37. Page 37 of the workbook. If the force of gravity on the beam in the diagram below is 1,200 newtons, what force must be exerted at A and B to maintain equilibrium? And in what direction must each of the forces act? Well, we have to make sure it's in equilibrium. So A and B could have forces up or down, and there's going to be a center of gravity that has a force of gravity down there already. So A and B can both be up, down, or in opposite directions. That leaves us with these options. That the first one up to the right here, we'll call it A, has all the forces down, FA and FB down, as well as the center of gravity. If we do B with up, we'll do C with A up and B down. And the last option of placing the forces A and B will be D with FA down and FB up. Now, when it says what forces and in what directions to maintain equilibrium, there's two types of equilibrium here from static equilibrium. We know there's translational equilibrium, where the sum of the forces have to equal zero. And there's rotational equilibrium, which is sum of the torques have to equal zero. So definitely A is not the answer. We cannot have all forces down and make them add to zero. Okay, with these three forces down, it will not be translational equilibrium. It could be rotational equilibrium. It might not rotate, but it's definitely not in translational equilibrium. So A is not the option. So you make a guess. If it's not A, is it B, C, or D? Come back next week for the answer. Welcome back. This is next week. Let's get the answer. Well, if both A and B are this way and center of gravity is that way, it might pivot around there. Definitely not in rotational equilibrium. It's not B. C, same thing. These two forces are down. That force is up. This is going to cause a rotation. Not in rotational equilibrium. So, matter of elimination, it will be D. So translational, if it is translational, that means FB is equal to FA plus FC, the center of gravity. So the up equals the down. In rotational, it could be rotational, that this is pulling it this way and this force down here is pulling it that way. It could rotate and be balanced. So let's just clear this up. So D was the answer. I've copied the free body diagram of D up to the top here. We don't know what this is, and we don't know what that force is. We're going to solve this by using the sum of the torques, and we will want to put a pivot point at one of those forces, because then the torque, which is force times distance times the sine of the angle between them. If D is 0, meaning the pivot point's at that force, then it will not cause a torque, and this torque will disappear in the sum of the torques, and that's what we want. So let's put the first time, if there's going to be 2 times, we'll put the pivot point at A. So we'll do the sum of the torques equals 0 when the pivot point is at FA. So the torques clockwise is equal to the torques counterclockwise. Clockwise is forces this direction, and that'll be the center of gravity. So clean that up, and so the torque caused by the center of gravity has to equal the torque caused by the force B. So we need now some distances and some forces. So this is going to be force times distance times the sine of theta is equal to the force times the distance times the sine of theta. And this is the force of the center of gravity. So that's why I'm going to write down 1800 newtons. The distance it is away, that distance there, will be 3.8. And this sine of theta, as I always do, all right, this is just 1, because the angle between the radial arm and the force is 90 degrees. And this is going to be FB, we don't know it. The distance away is 2 meters, and the angle here again is 1. So solving for FB, this gives us FB is equal, pull up our calculator, we'll do, oh, and I said 1800. Thank you. Let's correct that. I know some people are going to be already in the comments. 1200. Right there. So 1200 times 3.8 divided by 2. And that'll be FB. 2,280 newtons. And that'll be up. Give it the old direction. Make sure, because we needed the direction of them as well. Now there's 2 different ways to get FA. We can do it by the sum of the forces equals 0. That means the forces up equals the forces down. And the forces up is FB, and the forces down is FA, and the force of the center of gravity, this is 2280 newtons, and FA is what we're trying to figure out, and the center of gravity is 1200, so we'll subtract 1200 from this, and we can get FA that way, which is 1080 newtons down. Let's just show you that we could have done it by doing the sum of the torques. So I'll move the pivot point to FB, and we'll do the sum of the torques equals 0. So the torques counterclockwise is equal to the torques clockwise. The torques counterclockwise is the torque caused by FA, and the torques clockwise is the torque caused by the center of gravity. Again, let's just try to picture it, and I'll undo we'll put in the pivot point here, and this is clockwise, and this is counterclockwise. So that's why the torque of A has to equal the torque of the center of gravity. Okay, change the colors. The torque of A is force times distance times the sine of theta, and that has to equal the force times the distance times the sine of theta. And in both of these cases, the sine of theta is 1. And the force is what we're trying to find out, FA. The distance to the pivot point B is 2 meters. FA is from B is 2 meters. And this is the force of the center of gravity, which is 1,200 newtons times the distance, which is 1.8 meters. So FA is equal to 1,200 times 1.8 divided by 2. And it is the same answer as we had over there. Okay, whatever way you want to do it. And if you do it both ways, it's a good check. Thank you very much. Happy physicsing.